everyone, and welcome to Peptides, a series of debates from our leading candidates in reversed phase peptide separations. I'm your moderator, Paul E. Peptide, and it's my great pleasure to bring you yet another fascinating discussion. Today, we examine peptide loadability. In peptide mapping applications, one often looks for minor levels of peptide species modifications, say for instance, oxidation or deamidation from the vast majority of desired peptide fragments. Kind of like searching for a needle in a haystack. Which of you might be best suited for this application? BEH, let's begin with you, shall we?
Where do I begin? Yes, of course it's obvious I'm fit for purpose, as cited in many publications. People have trusted my performance for many years because I can not only be used for a wide range of peptide types, but I am also very adaptive, especially for optical separations using 0.1% TFA, and able to generate sharp symmetrical peaks and high peak capacities.
Mr. Peptide BEHC18, if I may call you that, I agree that you generate good results when used with 0.1% TFA for use in LC-based peptide separation applications. However, you must certainly realize how much additional information can be used using mass detection. It's only I deliver such outstanding performance in either 0.1% TFA or 0.1% formic acid. In addition, one can successfully load more peptide digests on my chemistry versus yours, making finding that needle in a haystack much easier. Plus, use of LCMS with 0.1% formic acid helps users determine what their small peaks are, not just how much is there. Who's more flexible now, dude? Have you seen the publication in the Journal of Analytical Chemistry? I have outstanding performance, not only at typical peptide mapping mass loads, but even at 10-fold lower mass loads on the same size column as you, BEHC18. This means you don't have to load a lot of sample and compromise peak shape. Not to mention that this is unparalleled loadability even when compared to 100% silica-based columns, and that's how I make finding that needle in a haystack of peptides possible.
I have no comment.
I didn't think so.
In order to detect low-abundance species, it appears that the peptide CSHC18 candidate delivers remarkably better performance even at low sample load concentrations required for either the LC or LCMS detection. And with that, we conclude another exciting round of debates with these three nominees. Join us next time and find out which one of our esteemed candidates has the right stuff. See you next time!